So today I will be looking at my arc length project in which I will be trying to estimate the length of a generated path that I made using arc length integration as we learned about in class. So my main goal will be to determine the length of my average dog walking path using this arc length integration technique. And just for reference, this is the walking path I have generated. Now, as you can see, it is clear that there are both function parts to it as well as straight lines. And my first step was to break them down into these separate parts. So as you can see here, there are three functions, 1, 2, 3, as well as two straight edges, 1 and 2. So first I looked at the straight line aspect, and that was relatively simple. I would just use the ruler tool to measure out the length on both sides, which included 1,060 feet and 352 feet. And next I moved on to the functions. So my first step with functions included generating a hypothetical x and y axis. And then based on it, I would generate x and y coordinates to plug into my regression plot. So this was done using a ruler tool. So once again, I generated a hypothetical x-axis as seen here. Then I would find around the area I wanted to be my point, place a point down, and then extend to achieve both my x and y coordinates. And mostly I focused on generating zero values, maximums and minimums, as well as endpoints for the function. These points were then plugged into a graph regression, as you can see here, and the best trend line was generated, and the formula here was recorded. To find the arc length, I ended up taking the derivative of this function, as you can see here. Then I ended up plugging this derivative into the arc length formula, which involves taking the integral from these two bounds and taking the square root of 1 plus the derivative squared. And it was generated that there was 1,255.62 feet for this particular function. Next, I moved on to the second function, and I did a very similar procedure in which I generated that x and y axes and found various key points that I thought would be important to generating a function, such as this maximum here, these two endpoints, and of course a 0. Once again, it was plugged into the same regression program, and this function was generated. From there, once again, I took the derivative of the function and plugged it into the arc length integration formula to find that this had a length of 750.058 feet. Finally, I moved on to my final function. Now, ideally, this would have been a straight line, but clearly there is some degree of curving, so I was forced to do a similar protocol to the previous two functions. Once again, I generated these points on a hypothetical x and y axis. These points were then plugged into this model, and the best fit trend line was found, which clearly is not ideal, but anything different would have been too far out. And the generated function is seen below here. The derivative was taken of that generated function, and it was plugged into the arc length integration formula, and it was found that this function had a length of 535.673 feet. So finally, to put all of this information together, I ended up adding every single length that I'd found, including both functions as well as the straight edges. So once all of these values are added up, it was found that there was roughly 3,953.35 feet in my walking path, or it could also be expressed as 0.7487 mile long path. Value can ultimately be compared to the number generated by the program, and as you can see here, the program believed that the distance was 0.748 miles, which, although mine has one extra decimal point, it can be pretty much seen that there was a 0% error.